So let's have the law of conservation of energy. So this is a universal law, just like universal gravitation. So it applies at any point in the universe. That ano ba yung law of conservation of energy? Sa law of conservation of energy, energy is not created or destroyed. It is only transformed from one form to another. Okay, one form to another. So I think you have heard, have you studied this in high school? I think you have. Okay, so this is one of the most important laws in physics kasi it applies to all the laws, all situation. So sa lahat ay ina-apply yung law of conservation of energy. Lalo na pagdating sa physical world, may matter, lahat ng matter is considered na merong energy. Ayan. Okay, so let's have some review of energy. So we have kinetic energy. We have discussed this, which is associated to movement, or sometimes we call it the energy in motion. And then we have the potential energy, which is determined by the configuration of the system. So this is like the energy for gravity. So kailangan merong kang elevation or height from a specific reference like the ground para makuha natin yung potential energy. Ayan. So that's why sometimes they call this energy in position kasi nakadepende siya sa isang reference. And then yung pangatlo, yung internal energy, this is something that we haven't discussed last time. How will I discuss this? Okay. So wala kayong question dun sa unang dalawa. So let me discuss the third one, yung internal energy. Okay. Hey class. So let's say that we have an object. We have an object on the surface of the earth. Okay, ayan. And the object is not moving. So that means it does not have kinetic energy. Yes. Kung reference natin ay ground, since nasa ground siya, so therefore, wala rin siyang potential energy. Okay? So that means yung energy nito ay zero, ganun ba? Zero. Okay. Pero ano ba yung sinasabi nating internal energy? So if you will get a portion, even if the object is not physically moving or it is on the surface of the ground, so that's why its kinetic energy and potential energy are zero, pero meron pa rin naman siyang energy. So kahit hindi siya gumagalaw, so yung energy na internal is somewhat related to the microscopic part. So let's say I will get a portion of that and then we will zoom it. We will zoom that portion. Diba, if this is a solid, diba yung solid is made up of, diba meron tayong mga atoms. Tama ba? Ang solid is made up of atoms. But these atoms, lalo sa solid, di ba compact sila? Compact yung mga atoms na to. And are they moving? Gravitational potential energy, we considered it zero since ang ginagawa nating reference is the ground. So, in configuration, if our reference is the ground, it's somewhat yung potential niya ay nagiging zero kasi nasa zero height siya. Di ba yung formula natin is mgy, wherein y becomes zero kasi nasa reference siya. So that's why yung potential niya ay nagiging zero. But it doesn't mean wala pa rin siyang energy. Kasi if you will consider the atomic part ng, let's say this one is a solid block, so it is made up of atoms, yung matter. And these atoms, lalo na sa solid, di ba compact sila? And they are moving very fast. So these are moving in random. So they are moving in random and they are bumping with each other. And since they are moving in random, so that means meron silang energy. And yung energy na yon ay tinatawag nating internal energy. So yung internal energy, yun yung pinopossess ng mga yan, dun sa subatomic part. So parang yun yung analogy niya na internal energy, something kung wala siyang potential and kinetic, at least yung mga molecules na may made up yung solid or yung matter. So meron pa rin silang energy, kaya nag-move sila. Okay, so remember yung tatlong state ng matter? Di ba yung solid, liquid, and the gas. Kaya lang meron pang dalawa. Ano yung dalawa? Naalala niyo ba ano pa yung in-state nilang dalawa? Okay, yung plasma, yeah. Highest dito is yung gas. In terms of temperature or in terms of higher level, pinakamataas yung gas kasi in terms of temperature niya mataas. And then, sobrang-sobrang taas pa niya, nandoon yung plasma. Okay? So, nandoon yung plasma. Yung plasma is something na super, super hot. Kaya parang hindi mo daw siya matitest kung hindi mo siya kasi malapitan, hindi mo siya matouch, hindi mo siya mano. Kaya, yung plasma is sobrang-sobrang taas ng level niya compared dun sa gas. Okay? Gas state. Kaya lang, on the opposite side, meron kabaliktaran. Okay? Kung nandito sa side ng gas yung plasma, nasa bandang side naman ng solid yung isa. Na-encounter niyo na ba ang BEC? Yung Bose-Einstein condensate. Have you heard of it? Yung Bose-Einstein condensate. So that is the opposite of plasma. Kung ang plasma is sobrang init, yung Bose-Einstein condensate naman ay sobrang lamig. Kung tubig ang pag-uusapan, di ba, ang liquid ay yung water and then solid yung ice. Okay, ang ice, ang water kasi is nagsusolidify siya at 0 degrees. Pero, di ba may temperature naman na sobrang baba. Kaya yung mga nasa state na yan, normally nasa malamig na lugar and even do sa mga malalayong planeta, yung Bose-Einstein condensate. Kasi sinasabi nila, even pag yun daw isang matter ay nag-under siya sa state na BEC or Bose-Einstein condensate, nagiging zero yung energy niya. So even yung molecules, imagine niyo solid na yan, pero yung molecules, humihinto pa rin silang gumalaw. So ibig sabihin daw nun, pati yung internal energy ng matter ay nagiging zero. Kasi even the molecules, hindi na sila makagalaw. Kaya nagsi-zero na yung energy doon sa sobrang lamig na Bose-Einstein condensate. Okay? Kaya related ang internal energy sa temperature and then doon sa state din ng matter. Okay? Ayan. So anyway, later we'll be discussing more of that. Okay, so may question ba sa internal energy? So even if it does not have kinetic, it does not have potential, at least uh, the object still has energy, and that's internal energy. Okay, so ngayon ay yung system naman. So meron tayong dalawang types of system, yung isolated system at saka non-isolated system. So ganito lang ibig sabihin yan. Kung meron tayong system, okay, pag sinabi mong isolated, so walang pwedeng pumasok or lumabas na energy. Okay, at any point in time, yung net energy is equal to zero. Or the change in energy is equal to zero. Total energy is equal to zero. Pag sinabing isolated, so hindi pwedeng pumasok or lumabas yung energy. Pero pag sa non-isolated, so that means energy can come in and come out. So that means the change in energy at any time will not be equal to zero. So pwedeng merong work done on the object, pwedeng yung object yung nag-work, pwedeng may friction, pwedeng may radiation, something like that. So at any point in time, the energy, the change in the total change in the energy is not equal to zero. Or the total energy in the system is not equal to zero. I mean the change. Pero pagdating sa isolated, since hindi pwedeng lumabas or pumasok yung energy dun sa system, that means at any point in time, there's no change in there's no change in the total energy. So regardless of the form of the energy, walang magbabago dun sa total energy. So kung yung simula ng system ay 10 joules lang, tapos nag-drive siya, 10 joules pa rin ang total energy niya after some time. Pero hindi kagaya sa non-isolated, pwedeng 10 joules lang siya nung nagsimula, pwedeng 20 joules na siya pag natapos, or maging negative man or maging 5 joules na lang. Kaya lang yung ibig sabihin ng isolated. Pag isolated, hindi pwedeng pumasok, lumabas yung energy. So pagdating sa non-isolated, so pwedeng lumabas or pumasok yung energy. So pwedeng madagdagan, pwedeng mabawasan sa non-isolated. Pero sa isolated, yung total energy is the same at any point in time. Okay? Ayun yung conservation of energy, ayan. So can be used in if no non-conservative forces act within the isolated system. Applies in biological organisms, biological systems, engineering situations, etc. Ayan. So yung conservation of energy, the law, that means its energy is not created or destroyed. It is only transformed from one form to the other. Ay, nagmarka. Okay. So meron tayong ways to transfer energy in and out of the system. So this is for non-isolated. Okay, so energy can go in and out of the system. So that means energy at a point in time will not be the same. Okay, so mag-change na siya. So in terms of work, if there's a work done on the object, in terms of mechanical wave, so allowing disturbance to propagate through a medium. In terms of heat, okay, heat is in terms of a change in temperature. So pag nagbago yung temperature, it will change also the energy of the system. Matter transfer. So matter physically crosses the boundary of the system, carrying energy with it. Okay. Electrical transmission. You know what's happening pag nagta-transfer ng energy. Pag nanood ka ng TV, later I will discuss that. And then yung electromagnetic radiation. Ayan. So itong anim. So ito yung anim na paraan para ma-transfer yung energy sa system. In and out. Okay? So yung conservation of energy, so this means that they cannot be created or destroyed. So mata-transform lang siya from one form to the other. Okay? So halimbawa, ito lagi kong in example ito. Bakit pag sinabing conserve energy, di ba electricity lagi yung kino-conserve natin? Okay, sa halimbawa ay paano ba nabubuo yung electricity or yung paano ba yung nangyayari sa bawa nanood kayo ng TV? Saan ba nanggagaling yung energy na ginagamit ninyo? So di ba halimbawa, meron tayong windmill. Yan. Hindi ako marunong mag-drawing. Ayan. Okay. Siyempre, para gawa na yung windmill, kailangan mo ng wind na may speed. So, yung wind na yon ay sabihin na natin meron siyang mechanical energy or kinetic energy. So, yung kinetic energy ng wind, matatransform, paikot niya yung blades na to, at yung energy na yon magiging mechanical energy. And since may generator yung windmill natin, so yung mechanical energy matatransform into electrical energy. Yan. Pag na-transform na electrical energy, itatransmit na siya. Okay? Itatransmit na siya. Pag din-transmit na siya, habang nagta-travel siya, possible kasing umiinit yung kuryente, yung mga wires dito. Kaya yung iba ay natatransform into heat. Okay? And then, yeah. Mm-hmm. And nagta-transform lang talaga yung mga energy natin. Okay? And then, pag naging heat na, may heat, some of the energy, pag nagta-travel dun sa wire, pwedeng matransform into heat. And then, halimbawa, dumating niya dun sa bahay ninyo, tapos sinaksak nyo siya dun sa yung TV nyo, tinaksak ninyo, ayan. So, pumunta na siya dito sa TV. And some of the energy will be transformed into light and even to sound. Kaya siya naririnig. And then some of them, syempre, umiinit din yung TV, matatransform na naman into heat. Okay? And then, yung iba, radiation. So, syempre, pag nakita ninyo, narinig ninyo, syempre, papasok sa tenga ninyo, magta-transform na naman siya into energy. And then, yung mata ninyo, magta-transform na naman into energy, yung nakikita niya. And then, siyempre, pa-process niya yun, pwedeng uminit yung ulo niya, matatransform na naman into heat. So that is how energy is created nor destroyed. It's only transformed from one form to the other. Okay? So, halimbawa din, gets ba? So, halimbawa, meron akong object, o free fall naman tayo, no? Free falling body. Siyempre, yung object natin, hindi naman siya tataas kung wala kang i-apply na force, di ba? So, siyempre, gumamit ka ng energy para bigyan mo siya ng kinetic energy, di ba? Para bigyan mo siyang kinetic energy, so nag-work ka. Okay, so habang nagta-travel siya pataas, di ba? Yung kinetic energy niya ay bumababa, pero yung potential energy niya ay tumataas. Kasi yung height niya ay nagbabago. Okay, so habang tumataas pa siya, yung kinetic na niya ay bumababa na naman, tapos yung potential energy ay tumataas. At pag na-reach na yung kanyang maximum height, di ba yung kinetic energy niya ay nagiging zero, tapos yung potential energy niya nagiging maximum. And then magsisimula na naman siyang bumaba. So that means yung kinetic energy niya ay pataas na, pero yung potential energy niya ay pababa na. Hanggang bumalik na siya sa baba, na yung kinetic energy tumataas ng tumataas at yung potential energy ay pababa ng pababa. Okay? So, natatransform lang yung energy from one form to the other. Di ba yung kinetic energy natin ay 1/2 mv squared at ang potential energy natin ay mgy. Okay? Lalo pag sa isolated, purely, pag in-equate natin yung change, is equal to zero. So that means yung full kinetic niya is natatransform lang siya into potential, and pag bababa na siya, vice versa, yung potential natatransform into kinetic. So that is the law of conservation of energy. So energy is not created or destroyed, it's only transformed from one form to the other. So yung mga sinabi ko sa inyo types of energy, uh, yung common lang yan. So yung iba kasi, hindi ba natin pag-uusapan? Okay? May question? May question ba kayo? Ayan. Kaya class, naniniwala ba kayo sa global warming? Nasingit ko lang yung subject natin. Nanin, ano, magpapapol pa ako? Parang ako, parang, ayan, naniniwala. Naniniwala. Hindi. Hindi. Okay, unless baka napapressure lang kayo sa akin kaya nasabing naniniwala. Okay, bakit ko lang nasabi personally class, I am, uh, ay hindi, meron tayong hindi. Bakit? Sige, anyway, it's your opinion. Ito lang naman opinion ko, no? Ako medyo ano ko sa environment. Di lang mukha, pero talagang ano ko sa environment. When we are talking about this law, okay? And talking about global warming and talking about greenhouse effect and yung greenhouse gases. Okay? Ang Earth ay kumukuha siya ng energy primarily sa sun. Do you agree? The primary source of energy of the Earth is actually the sun. Okay, for education naman purposes ito. Okay? Imagine ninyo, if the sun is radiating and it is releasing a lot of energy towards the Earth, kaya lang, ang problema, based on this law, energy is transformed from one form to the other. No energy is being returned or being moved out of the Earth. Lahat ay natatransfer dito. Pero, sino ba yung directly nakakagamit lang ng energy binibigay ng sun? So, di ba sinasabi nila, magbilad ka daw ng umaga para yung vitamin D, something like that. Yeah, it helps, really. And even in solar panels, yes, natatransform nila ang solar panel, yung rays ng sun into electrical energy. Pero, di ba, limited lang yon. Ang problema kasi, ang pinaka gumagamit lang talaga, naturally, maliban sa tao, ay yung mga halaman. So if you know your food chain or even if you know your photosynthesis, the plants can produce food pag naarawan sila. Kaya sila yung pinaka gumagamit ng sunlight talaga, na tinatransform talaga nila yun naturally, yung sun, yung energy from the sun into something useful. Like pagpuproduce nila ng food. At pag nagproduce ng food yung plant para sa sarili nila, nagpo-produce din siya ng food para din sa atin, na sa lahat ng ibang organism. Kaya lang ang problema, kung nawawala na yung mga puno, mga halaman, anong mangyayari doon sa energy na binibigay ng sun sa earth kung wala naman gumagamit at hindi siya na-utilize? Di ba nag-stay siya sa earth? Tama ba? Nag-stay. Hindi lumalabas sa earth. Kaya, ayan, marami-daming energy sa earth. Na-stock yung lahat ng energy sa earth araw-araw because of that. Kaya, yan. Yan ang nangyayari sa atin. Nagkakaroon ng climate change. So ay naniniwala din ako sa climate change. Unless we change our ways para hindi masyadong mabilis yung pagbabago ng climate or even yung pag-init ng earth. Ayan. So one way for me, I think, one way to help yung pagbagal ng ganon is yung pagtatanim talaga ng halaman. Kasi sila talaga yung pinaka nakakagamit ng energy from the sun. Okay? Pasakali ko lang. Okay? Question ba? Let's continue with our lesson. So you start planting plants. Okay. So nandito na tayo sa pinaka-importanting form. May question ba kayo? Baka gusto niyo yung maki-argue sa akin. I don't want to argue. O baka may question lang kayo. Okay. may sense naman yung sinabi ko. Because of this law. I really like this law. Okay. So let's continue. Now, mathematically, ayan, for non-isolated, so yung energy, total energy change in the system is equal to the total energy transfer. Okay, so lahat ng nagbago doon sa system, lahat ng change doon sa system is equal siya doon sa nag-transfer. So halimbawa, ang sinasabi ng, halimbawa, so meron tayong isang system na 10 joules yung total energy. So tapos, may ginawa tayong work doon sa system, so naging, nadagdagan siya ng 5 joules. Ayan. So syempre, yung total change in the system will be equal to 5 joules. And yung 5 joules na yan is the total energy transferred. So ang energy is just plus minus. Kung ano lang yung nadagdag, ano lang yung nabawas, ano yung total, yun yung change. Okay? So, yan lang ibig sabihin nito. Na yung total change in the system, the energy in the system, is equal to dun sa total transfer. Ayan. So, yung transfer na yan is nandito sa 6. Kaya, klase, ito yung formula natin. Yung total energy sa system, itong tatlo, ayan, nakita nyo yung tatlo, the change in kinetic plus the change in potential plus the change in internal is equal to the total energy transfer through work, through mechanical wave, through heat, through matter transfer, through electromagnetic radiation, through electric transmission, and through mechanical wave. Ayan. So ito kasi lahat ng matter transfer. So yung lahat ng energy na na-transfer based on the 6 will be equal to the change in potential plus the change in kinetic plus the change in internal. Okay. So, yun lang isipin nyo, plus minus. Kung ano yung nadagdag, yun lang naman yung nagbago dun sa energy ng system. Pwede yung nadagdag na transform into siya kinetic, na transform siya into potential, or na transform siya into internal energy. Ayan. Okay? Klase ito yung pinaka-importante gagamitin lang natin. This is always the formula. Ayan. So, isolated system ay wala naman masyadong kaso dito. So, yung mechanical lang, pag sinabi mechanical energy, that is the sum of potential and kinetic energy. So, kung change in mechanical ang pag-uusapan, so that's equal to the change in potential plus the change in kinetic. Okay, pag conservation, yung change in isolated kasi yan, the total change in the energy in the system is zero kasi wala naman na transfer in or out. Okay? And then yung pag-friction naman ang pinag-uusapan, ayan, class. Ito na. Ang frictional force, nakikita niyo ba to? Ang frictional force, okay, the total change in internal energy is equal to the work done by friction. Ayan. That's the frictional force times the distance kung saan may friction. Okay? Yung distance kung saan may friction. That is the change in internal. Okay, class. Ano bang napoproduce pag merong friction? Tama. Heat. Anong ginagawa ng heat sa mga molecules? Okay, pinapagalaw, pinapabilis. Kaya tumataas yung internal energy. So even hindi gumagalaw yung object, wala siyang potential, wala siyang kinetic, pero pag nagbago or tumaas yung kanyang internal energy, that means yung mga molecules na yon ay masyadong mabilis gumalaw. Okay, because internal has something to do with the molecules. So therefore, kung may friction na nag-produce siya ng heat, napainit ang mga molecules na to, syempre bibilis sila, kaya tataas yung internal energy. So that's why, if you will be asked kung ano ang change in internal energy, that's equal to the work done by friction. So in work done by friction, binago niya yung internal energy ng ating system. Kaya pinataas niya yung energy. Okay? So yun lang yung ibig sabihin ng slide na to. Okay? And then, eto na yung ating susunod, last na to, is yung power. Ayan. So power, ayan, power is equal to work done over time. So ano ba unit ng work? Work is joules, and then time is second. And that's the same as what? Okay, 1 watt. Okay, 1 watt is equal to 1 joule per second. Okay, so meron tayong mga, ayan, iba-ibang formula ng power, pero yung pinaka-formula ng power para sa ngayon, wala yung power nyo sa electricity, sa iba pa yon, ibang usapan yon, wag dito muna. Pero same lang sila. Ayan, so it's also the same as yung force, that product ng force at saka ng velocity. Okay, so that's the same, that product ng force and velocity. Okay, and then ano ba yung unit ng power? Ang unit ng power ay, ayan, so 1 watt is 1 joule per second, and 1 unit of power in the 1 horsepower is equal to 746 watts, and then 1 kilowatt hour is equal to that one. Ay. Okay? So, any question? Okay, class. So, ang pinaka-formula na kailangan natin itandaan dito ay yon, yung ating law of conservation, yung delta K plus delta U is equal, plus, sum up ko na siya. So, negative FKD plus W. So, this is the most important formula na gagamitin natin pagdating sa work conservation of energy. Okay? So, yung W na yan is work done by outside forces. So, sinamap na lang natin yung 6 na transfer into W. Kasi yung W, pwede rin naman siyang nandoon yung sa mechanical na spring. So, work done of a spring, pwede siyang isali dito sa W na to. Okay, so delta K plus delta U, the change in potential plus the change in kinetic is equal to the negative of the work done by friction plus W. Kung wala yung mga yan, iyan lang natin sila. Isi-zero lang natin. May friction ba? Wala. Zero. May work done by other forces ba? Wala. Zero. So, di ba mag-equal siya sa zero? So, babalik siya ngayon sa isolated. Magiging equal to 0. So, yung sa mechanical energy. Okay? So, yun lang lagi naman gagamitin nating formula. So, this one. Okay, my question? Okay, pag isolated, 0 lang natin. Or pag isolated, ang K final plus U final is equal siya sa K initial plus U initial. Potential energy final is equal to ayan, the total energy initial. So this is E final, that's equal to E mechanical initial. Kaya pag tinransfer natin sila, so the change in mechanical energy is equal to E final minus E initial, which is equal to 0. Pag isolated. Okay? So let's have our first example. Nakikita niyo ba yung drawing? Nakikita niyo ba yung drawing? Malinaw ba yung drawing? Hindi ko sure kung malinaw ba yung drawing or hindi. Sakto lang. Sige. Okay. Thank you for confirming. So the diagram below shows a 10,000 kilogram bus traveling on a straight road which rises and falls. The horizontal dimension has been foreshortened. So meron tayong mga dimension dyan. So yung bus natin na sa 55 meters, siguro sabihin natin about sea level or whatever, 50 meters sa B, then we have 60 meters and then 65 meters. So that is vertical elevation, okay? Vertical elevation. Nawawala yung mga questions. Hindi ko na-copy. Teka lang, yung print ko, nakalimutan ko. Ayan. The speed of the bus at point A is 26.82 meters per second. The engine has been disengaged and the bus is coasting. Friction and air resistance are assumed negligible. So the number on the left shows the altitude above sea level in meters. The letters A to F correspond to points on the road at this altitude. Sabi ko na yes. Okay? So ito ay mga sea level yan, elevation. So yung bus natin ay initially at point A na above sea level na 55 meters. Ayan. So ito na yung mga question. Hindi ko siya na-add. Ayan. Question letter A. Find the speed of the bus at point B. Find the speed of the bus at point B. Okay, class. Kung gagamitin natin ay yung general formula, so delta K plus delta E is equal to negative FKD plus W. Okay? So, meron bang friction na involved? So, walang friction. So, this is 0. Meron bang work done by other forces? Wala, 0 siya. So, that's why delta K plus delta U is equal to 0. Okay, bakit siya equal to 0? Kasi sinabi naman dyan na, ayan, negligible naman yung mga yon. So, pumunta siya sa isolated. So, meron lang is kinetic and potential energy. So, kung kukunin natin ng K, delta K, so that's K final minus K initial plus U final minus U initial is equal to 0. So, K final plus U final is equal to K initial plus U initial. So, yun ang formulang gagamitin natin. Okay? Ngayon, first question ay, letter A. Find the speed of the bus at point B. So, ano daw yung speed at point B? Okay, so i-compare natin, syempre, meron tayong information sa B, sa A at saka sa B. So, i-compare na lang natin. So, delta KB plus UB is equal to KA plus UA. KA plus UA. Ayan. Sandali. I-fold ko yun para makita natin yung drawing habang solve natin. Ayan. So, yung compare lang natin is A and B. Okay? So, anong gagamitin nating reference? Kasi pag potential ang pinag-uusapan, kailangan natin ng reference. So, ito niyan ay magiging 1/2 mVB squared plus mGYB is equal to 1/2 mVA squared plus mGVA YA. Ayan. Okay? So, ano magiging reference natin? Kaya actually, pwede naman natin i-divide na ng M. Tama ba? Divide natin ng M para mawala na yung M. Okay? Pero, ano gagawin nating reference? Point A or point B? You decide. We need a reference. References for potential. Siyempre, kung ako yung mababa, yun na lang yung gagawin nating reference. Okay? So, yung reference natin ay YB is equal to 0. Kasi ito yung gagawin nating reference. Okay? YB is 0. So, if YB is 0, so what is YA? YA. Okay, 5. Tama. 5. Correct. 5 meters. Ayan. Okay, what ibaliktad? If YA is 0, what is YB? Negative 5. So, yeah. Tama, Jim. You're correct. Okay, pero ako, lagi ko reference yung sa baba na lang para puro positive yung sagot ko. Tama ba? Pero syempre, kung gusto nyo, actually kahit sa E pa yan, pwede naman. Kung gusto nyo reference E, wala namang problema. Kung E yung reference natin, ano yung A nun? So, kung E ay 65, 55, negative 10. Ano yung B natin nun? Negative 15. Ayan. Pero ako gusto ko nagsi-zero yung at least isa para wala tayong kino-compute, di ba? Tama ba? Okay, so that means this one will become 0. Ayan. Okay? Substitute na lang natin. Ano ba yung VA natin? Given ba? Okay, VA natin ay 26.82 meters per second. So substitute lang natin. Class divide ko na yung M, no? So cancel na natin yung M kasi lahat naman sila ay may M. Ayan. So 1/2 VB squared is equal to 1/2 times 26.82 squared plus 9.8 times 5. Ayan. And then multiply this by 2. So VB squared is equal to, dinivide ko na siya ng M. Kinancel ko na. Ay, sorry. Nakikita nyo ba? 0.2 times 26.82 squared plus 9.8 times 5 times 2. Yan, 385.72. Then square both sides. So the speed of B is 19.64 meters per second. Okay? 19.64 meters per second. Question? Mali ba? Okay. So next, letter B. Ay, sandali. Ano ba yung question? Next question. An extortion ba yan? An extortionist has planted a bomb on the bus. If the speed of the bus falls below 22.35 meters per second, the bomb will explode. will the speed of the bus fall below this value and explode? If you feel the bus will explode, identify the interval in which this occurs. Okay. So, class, tinatanong niya, magfo-fall ba daw yung speed ng bus ng 22.35? Okay. Ayan. Okay, class. Pwede bang yung iba ay sagutin ang B, D? Kailangan natin malaman ang speed. Okay? Una, ano yung speed? Nakuha na natin yung speed sa B. Pangalawa, ano ang speed sa C? Ano yung speed sa D? At anong speed sa E? Kailangan natin malaman yung tatlong yon kasi i-check natin kung bababa ba sila ng 22.35. So pag may mababa sa 22.35 na speed, sa point na to, doon sasabog yung ating bomba. Okay, doon sasabog yung bomba. So, sige. Okay, class. Ready, set, go. So, can someone who wants to... baka, Adrian. So, ipapost ko muna. Minemory clear ko muna. So, it should be 817.31. It's 28.59. Yan, tama na ba? Okay. Para nagtataka ako kasi dapat tumaas siya dito, di ba? Namulan siya ng potential. Tapos dapat matatransform into kinetic. Nagtataka ako bakit bumaba. Okay, kaya, ayan. So, in-expect natin na dapat tataas yung kinetic niya kasi nabawasan yung potential niya. Ayan. So, in-expect naman din natin dito, dapat bababa kasi nabawasan yung kinetic, nadagdagan naman ng potential. Ayun. So, I'll give you, can somebody answer what's D and what's E? Waiting ko. Okay, so hindi ko na-record yung kanina. So, ito yung sagot natin kanina. Okay, so based on sa question, dapat pag bumaba ng 22.35 yung velocity, sasabog yung bomba. So we have computed that the point at point D, the velocity at point D, the speed at point D is only 24.93, which is still higher than the detonation speed. And then yun sa highest peak natin na point is point E na ang speed is 22.87, which is still higher than 22.35. So therefore, the bomb will not explode at any point in the track. Okay? Ayan. Okay, now let's proceed to the second one. A ball with mass of 2 kilograms is dropped from the top of a building. This building that is 30 meters high. What is the approximate velocity of the ball when it is 10 meters above the ground? Okay, since ang lesson natin ay energy, it's not free-falling body. Okay, it's not free-falling body. So we will solve it using energy consideration. Okay, so let's say we have this tall building. Ayan, so nandito ay 30 meters. So initially, nandito siya at ang initial speed ay 0. At ang mass niya ay 2 kilograms. Ang tinatanong ay, kung dinrap siya, approximate velocity 10 meters above the ground. So if this is the ground, so 10 meters nandito. Okay? At this point, ano daw yung kanyang speed? Ay, velocity pala. Okay, velocity. So dalawang ko-compare natin dyan. Ito yung initial at ito yung final. So initial and final. Ayan. So gagamitin ang standard formula. So delta K plus delta U is equal to negative FKD plus W. Is there friction? Wala. So that's 0. Is there work done by other forces? Wala din. So that's 0. Ayan. So natitira ay non-isolated zero. So ito kasi, ibig sabihin, K final plus U final is equal to K initial plus U initial. Yan. So, ano lang natin? So, 1 half MV final squared plus MG Y final is equal to 1 half MV initial squared plus MG Y initial. Ayan. Okay? V final, so yan ang hinahanap. Y final, okay, anong gagawin nating reference? Okay, pwede naman ang ground ang reference. Pwede rin naman yung V final ang reference. Pero kung ako, gusto ko may magzi-zero na. Kung ako yun na, kung ako, tatanungin. Gusto ko ang reference ay isa sa mga point na yon para magzi-zero siya. Okay? Ako, suggestion ko, kung ako magsosolve nito, syempre ako magsosolve, ito ang gagawin nating reference. Okay? Para mag-zero na yan. Hindi na siya kasali sa computation natin. Okay? Next, how about V initial? So that's also 0. So therefore, this is 0. And then ang Y initial natin ay, syempre, nakabase siya sa reference. Kung itong reference natin, ano ang Y initial? Ano ang Y initial? Kung itong reference natin. So ano ang Y initial? $30. Are you sure? $20. Are you sure? Okay. So kasi siyempre, ito yung reference natin. So therefore, ito yung 0, di ba? So ano na lang height level nito? Yan, di ba kung 10 ito, syempre ito ay 20 meters. Kaya ito ay 20 meters. Okay? Kung ground yung ginawa nating reference, yung Y final natin nun is 10, tapos ang Y initial natin is 30. Nag-gets ba? Yeah. Okay? So, gusto ko kasi may nag-zero na para nababawasan yung sinusolve natin. Ayan. So, kakancel na rin natin itong M. Ayan, kakancel na rin natin. So, matitira ay 1 half V final squared is equal to G Y initial. So, that's equal to 1 half V final squared is equal to 9.8 times 20. So, anong V final natin? So, transpose and then square root. So, that will be 9.8 times 20 times 2, then square root. So, that's a 19.8 meters per second. Okay, velocity ang hinahanap. So, this is the speed. Speed lang yan. Okay, so therefore, dito ko na lang. Therefore, velocity is equal to negative 19.8 meters per second. Or 19.8 meters per second downward. Ayan. Okay? Downward. Kasi, tandaan ninyo, magkaiba ang velocity sa speed. Ang tinatanong ay velocity, not the speed. Pag speed yan, okay na tayo dito. Pero dahil velocity ang tinatanong, kailangan natin yung direction. Okay? Be careful with that one. The difference between vectors and scalar quantities. Eh, see, di ba? Kahit hindi tayo mag-kinematics, pwede natin i-solve yan. Using energy. Work and energy. Okay? So let's proceed to our, may question ba? Okay, we'll proceed to our next example. Ito ay, I will only start the problem and then you will continue with it. So I'll start it and then you'll continue with it. Kasi madali lang naman ito. Okay? So, meron daw tayong pendulum na ang mass is 405 kilograms and it reaches a maximum height of 2.4 meters. So, ang pendulum yan, siyempre, hindi ako marunong mag-drawing ng circle. So, yung maximum height niya, ayun, 2.4 meters. Ayan. So, ang tanong ay, what is its velocity at the bottommost point in its path? So, ano ang velocity dito? Ano ang velocity dyan? Okay. Okay, question. Same lang naman yan. Madidiretso na natin. So, wala tayong. Okay, so delta K plus delta U is equal to negative FKD plus W. So, wala tayo nito. Wala din tayo nito. So, babalik tayo sa K final plus U final is equal to K initial plus U initial. Okay, ano yung ina-assume natin initial? So, ina-assume natin initial ito. Initial at nandito yung final. Ayan. Ang question, di ba pag sa highest point, ang nagiging velocity ay? Di ba parang zero siya? Zero. Tama ba? Start siya doon, sa zero. Sinassume natin na yung velocity dito, initial, ay zero. So, tinatanong, ano yung final velocity dito? Ayan. So, okay. Sige nga. Try mo i-solve ito. Propose ko po. So, mamadaling ko lang. Tignan ko kung pareho tayo ng sagot. So, this is 1/2 mv final squared plus mgy final is equal to 1/2 mv initial squared plus mgy initial. So, v final, so yun ang hinahanap natin. Ano yung y final? Okay, so anong gagawin nating reference? Siyempre kung ako, ito, 9.7 ang sagot ni Jim. Okay, sige, we'll see. So, this is the reference. So, ito yung gagawin kong reference. So, V initial natin ay 0. So, 0, cancel. So, ano yung Y initial natin? So, syempre, so naka-base yung initial sa reference. So, Y initial. So, ano yung Y initial natin? So, ang Y initial natin ay okay, 2.4 times, kasi radius yan, di ba, circular, times 2. Ito, tama, that's 4.8. Yan, 4.8 meters. And again, cancel yung mass. So, matitira is 1/2 V final squared is equal to Gy initial. So, 1/2 V final squared is equal to 9.8 times 4.8. Then, cross multiply, then square root. 9.7. Okay, so 9.7 meters per second. Ayan. So, yun. Pero naman pala tayo. Tama naman pala ako. Okay? Ayan. So, ang susunod nating example ay, di ba madali lang? Yung favorite ko. Ayan. Favorite ko yung mga ganyan. Ayan. So, mag-spring na tayo and with friction. Kaya lang frictionless pala. Sabay-sabay na. Okay. Siguro marami akong i-explain dito. So, listen very well. Kung meron hindi naintindihan, you tell me. Medyo isa-sum up niya lahat ng formula natin sa problem na to. A 2 kilogram package slides along a floor with speed 4.4 meters per second. So, yung package natin is moving in this direction. Ayan, it's moving in this direction at the speed of 4 meters per second. It then runs into and compresses a spring until the package momentarily stops. Okay, so ang mangyayari, so papunta daw siya dito. So ang mangyayari ay i-compress na yung spring until momentarily hihinto yung package. Siyempre mangyayari, so ito yung ano. So mangyayari niyan ay hinto muna, tapos biglang itutulak ulit ng spring pabalik. Okay, tama ba? Hinto muna and then Pagka-press niya dito, taas yun to, ibabalik siya doon. Ayan. Its path to the initially relaxed spring is frictionless. So in this path, it's frictionless. But as it compresses the spring, a kinetic friction force from the floor of magnitude 15 newtons acts on it. The spring constant is 10,000 newtons per meter. By what distance d is the spring compressed when the package stops? When the package stops. Okay. So, dalawa ang tinatry nating i-compare dyan. So, dito, nag-stop siya. So, dito ay, so, ibig sabihin yan, class, ito yung gagawin nating initial point at nandito yung ating final point. So, yung i-compare natin, nung mag-start na niya i-compress yung spring, yun yung magiging initial point at yung momentarily pag-stop niya, yun yung ating magiging final point. So ano ba yung mga given? Yung frictional force na kinetic is 15 newtons and then yung ating coefficient of friction spring constant, it's 10,000 newtons per meter. Ano pa ba? Yung initial velocity is 4 meters per second. And then yung final velocity natin is 0 kasi mag-stop siya. And then the mass is 2 kilograms. 2 kilograms. Okay. So ito yung formula natin. Ang formula natin is delta K plus delta U is equal to negative FKD plus W. We have frictional. Do we have a work of spring? We have friction? Yes. How about work of other forces? We don't have an additional force, but we have a spring. So that will be the work of the spring. Okay. Hindi magkakasya dito. So, idilipat ko na siya ng paper. So, ang mangyayari dito niyan ay meron tayong K final minus K initial plus U final minus U initial is equal to negative FKD plus, ano yung formula ng work of a spring natin? Diba that's 1/2 KXI squared minus 1/2 KX final squared. Ayan. So, yun ang formula natin. Okay? So, ang formula natin ulit dito is 1/2 MV final squared plus minus 1/2 MV initial squared plus MGY final minus MGY initial. Di magkasya. Formula ko. So that's equal to negative FKD plus 1/2 KX initial squared minus 1/2 KX final squared. Ayan. Say natin. Ano ang V final? V final is 0. So we can cancel that. Ano ang V initial? So V initial is 4 meters per second. Ano ang Y final? Okay, class. Since this is horizontal yan. Is there a change in elevation? Okay, wala. Kasi magza-0 din. So same is true with Y initial is also 0. Kasi naka-horizontal lang siya. So that means this is 0 and this is also 0. Nagets niyo ba? Na class, ba't ng 0 yon? Because there's no change in height. There's no change in elevation. Okay? So that's why 0 silang pareho. Unless ito kasi mataas to or mataas ito. So magkakaroon ng change in height or elevation. Kaya hindi sila mag-0. Pero since horizontal lang naman siya, there's no change in height, 0 sila. Okay, ngayon, nandito na tayo sa isang importante. Okay, hindi na tayo sa FKD. So given tayo na yung FK natin ay 15 newtons. Okay, how about D? Okay, D is, di ba dito lang may friction? Yung pagkaka-compress lang niya. Di ba yung pagkaka-compress natin dito is based doon sa Hooke's law, it's yun yung X. So tatawagin natin yung X or D. Ayan. O pwede naman DX na lang. Yan, X. Okay, so yung D natin is yung X. Yan, yan yung pagkaka-compress ng spring. Kasi yun lang yung may friction. Kung ano lang yung distance or yung path na may friction, yun lang yung value ng D. Okay? Next, ano yung X initial? Okay, tapos ano yung X final? Okay, class, dito tayo magkakaano. Nung magsimula na i-compress nung spring, nung object yung spring, ano yung position ng spring? Initially, yung spring ba compress or naka-natural? Okay, naka-relax. Okay? So initially, yung problem natin, ano yung nung spring, position niya? Naka-relax. So therefore, X initial is 0. Okay? Next, nung final, ano yung position ng spring nung final position? Okay, nako-compress. So ano yung value ng pagkaka-compress? Okay, negative ano? Negative. Ayan, ano yung variable natin? It's X. Okay, so it's negative X. Ayan. So i-substitute lang natin. So kung 0 to, ito ay mawawala. Ayan. So ang matitira ay negative 1/4 times, what's our mass? 2 times 4 squared is equal to negative 15x minus 1/2 times 10,000 times negative x squared. Nag-quadratic pa ang sagot. Okay, kung i-simplify muna natin to. So that is, ba't 1/4 ang sinabi ko? 1/2. So that will be 16 lang din ba? Tama, no? 16. So negative 16 is equal to negative 15x minus 5,000 x squared. Ayan. So, quadratic formula lang natin. So, 5,000 x squared plus 15x minus 16 is equal to 0. So, by quadratic equation, what's x1 and x2? Mode 5, 3. It's 0.055 meter and negative 0.058 meter. Okay, so ano ang i-consider natin dyan? Okay, so yung i-consider natin sorry. Okay, yung positive yung i-consider natin dyan. Kasi, ayan, so distance lang ang pinag-uusapan, di ba? It's just a distance ng pagkaka-compress. So, ang i-consider na lang natin is yung positive. So, this one. Ayan. Kasi naka-square naman talaga yan. 0.055 meters. Okay? May question? Okay, class. Meron akong kailangan i-discuss sa inyo.